Hello, this is Satbir. The topic of our discussion in this video is the definite integral. Let's see what is the definite integral first. In the previous video, we learned how to calculate the area under the graph of a function by a technique which is also known as Riemann sum. What we do is we start by dividing the region into certain number of pieces and turn each piece into a rectangle. And then the area is approximate by adding the area of these rectangle. And we also notice if we increase the number of pieces, the area approximations get better and better. N is equal to 15 is much better approximation than n is equal to 10, and 20 is better than 15. 25 even is better, and 35 is very close to the exact area. And then we observe the exact area under the graph of the function. The graph of the function will be by taking the infinite many n, dividing the region into infinite many pieces and calculating the area of each piece, fx, that is the height of each rectangle, and delta x is the width of each rectangle, and then adding them up. This is the area of these rectangles, but we are taking infinite many rectangles. So that will give us if this limit exists, this will give us the exact area under the graph of the function. Now observe one more thing, that if in the previous example, our function was always positive, f of x is always strictly greater than or equal to 0. That means the graph of the function is always above the x-axis. What if the graph of the function is not above the x-axis? Some portion of the graph is below the x-axis. And if we do if we use the same Riemann sum technique here, we will see that by dividing the region into rectangular pieces, there will be some rectangles which will be above the x-axis, some will be below the x-axis. So if you calculate the area of these rectangle, it will give you a positive quantity. However, because the height of the rectangle is determined by the y value of the function. So here, when you will calculate the y value, it will be a negative. So this portion will be a negative area. And if you calculate this sum, instead it will give you the area under the graph of the function. It is going to give us the net area. Net area means area above the x-axis minus area below the x-axis. And this net area we will call the definite integral. If I take my n to infinity, so it means a to b f of x, this quantity will denote the net area, which will be the limit n approaches to infinity, summation I vary from 1 to n fxi delta xi. So this will represent the area above the x-axis minus area below the x-axis. So what is the definite integral? Definite integral is a quantity which is the area, which will represent the area under the graph of the function above the x-axis and minus the area below the x-axis. Let's take an example and calculate the area, calculate the definite integral by using geometry of the shape of the function. So here you can see that this definite integral minus 2 to 2. Since fx is a positive function, so there is no portion of the function is below the x-axis. So this will be the area under the function y is equal to fx. This definite integral will be just simply area above the x-axis. What will be the area of that shape if we use the geometry? This is a circle. This is the quarter of the circle of radius 2. So area is a pi 2 square, because this is the 1/4 of the circle, so I will divide by 4. The area of this shape, again I can divide this shape into two pieces. One is a square. The area of that square of length 2 is 4. 2 times 2 is 4, plus the area of this right angle triangle of height. Height is a 1 unit and base is a 2 unit. So it will be 1/2 2 times 1. If I simplify this one, this is simply pi, and this gives me 5. So my total area, the net area of this function is from -2 to 2 is 5 plus pi. So that is also the definite integral. Let's do one more example. Here our function is, some portion of the function is above the x-axis, some portion of the function is below the x-axis. And we are asked to calculate the net change of the function from -2 to 3 of this function. So it will be, by definition, it will be the blue area plus the green area, because these two portions of the function are above the x-axis, minus the red area, because that portion of the function is below the x-axis. So let's calculate what is the area of the blue region, which is a circle of radius 2, pi 2 square, because this is the quarter of the circle, so I will divide it by 4. Plus the area of the green region, which is 1/2, which is a right angle triangle of base 1, height 1, and the minus the red area, which is also a right angle triangle. So 1 time the base is 2 unit and the height is also 2 unit. So base is 2 unit, same as the height is 2 unit. So if I simplify this one, gives me a pi, this give me a 1/2, and this gives me 2. Therefore, this will be pi minus 3/2. This is the area of, this is the net change of the function f(x) minus 2 to 3, which is also known as definite integral of the function -2 to 3. Here I have one quiz problem for you to practice. Please pause the video for 1 or 2 minutes, and once you have your answer, you can leave your answer in the link above to compare with other audience. Now we will discuss what are the property of definite integral. It has 6 property. Very first property is, if you calculate the net change of the function from a to b, or you calculate the net change from b to a, if you reverse the direction of your integration, if you're calculating from a to b, so going from left to right, or if you switch the direction from right to left, the quantity will differ by negative sign. So you can switch the limit of the integration by switching the sign of the integral. Second and third property is, the second property, let's look at the second property first, is say that if you calculate the net change of the function starting from a point A and ending at a point A also, so that means you are calculating the area under a dot or under a point, which is just a straight line, and by notion the area of a straight line is 0. So therefore the definite integral starting from a ending at a, no matter what a function is always 0. For example, if I calculate what is the definite integral starting from 1 ending from 1 of function square root of x square plus 1 dx, it will be 0 no matter what is the shape of that function. Second one is, the third property is, if you calculate the change of the function from a to b, but the function is a constant and it has height 3 always, then the net change will be this area, which will be, if c is a positive, it will be above the axis, c is a negative, it will be below the x-axis, but the net change will be c time So it will be C times B minus A, which is basically the length of the base of the rectangle. For example, if you have 2 to 5 of function 4 dx, then the definite integral of that function is 4 times 5 minus 2. So constant time, the difference of the limit will be your net change of the function, which is a 3 is a 12 unit. Property 4 says that if you calculate the net change of the function starting from point A to C or then C to B, then it will be the net change from A to B. Or in other words, if you calculate the area from A to B and then calculate the area from C to D and then add them up, this will be equal to calculating the area under the graph from A to B. The property number 5 says the net change of the addition of two functions is the addition of the net change from interval A to B. And same properties hold for subtraction as well. And the property number 6 says that if there is a constant multiplier to a function, then the net change of the constant multiple of the function is equal to the constant time the net change of the function for any constant c, negative, positive, or 0. Let's use this property to calculate the definite integral in some examples. So here I have given the net change of the function 2 times of the function from 1 to 5 is a 12, and also have given the net change of the function from 4 to 5, and I would like to calculate the net change of the function from 1 to 4. So let's start writing down what is the net change of the function from 1 to 4 fx dx in term of net change from 1 to 5 and then the net change from 4 to 5. So if I basically write down the net change from 1 to 5, then I'm adding the one net change, which is equal to minus 4 to 5. So let's do this way. Let's start from here. So if I calculate the net change of the function from 1 to 5, 2 times fx, and I use the property that I can pull out the 2 outside, and then it will be a net change from 1 to 5 of the function fx dx. If I use that property, this is the property that you can pull out the constant, and then you use the property that net change of the function from 1 to 4 of the function fx dx is same as 1 to 5 is same as 1 to 4 and then 4 to 5 fx dx. 1 to 4 is what I needed because I need to calculate that definite integral. So I will basically divide 2 on the other side. I will divide that 2 on this side, and also I will move the other integral. So this will be 1 to 4 fx dx is equal to, if I divide 1/2 on both sides, it will be a 1/2 1 to 5 2 times fx dx, and then I will take that piece and subtract it. This is a 4 to 5 fx dx. Then I have the net change 2 times of the function is equal to 12. So this is going to be a 1/2 12, and minus net change from 4 to 5 is 7. So that's a 7. So this is a 6 minus 7, which gives you a -1. That is my net change from 1 to 4 of my given function. Here I have one more quiz problem where you will use the property of the definite integral to calculate the this definite integral. So this is the value of this definite integral is given, and you have to calculate the net change of the integral from 0 to 1. So these are your basically 6 options or the 5 options. So stop, pause the video for 1 and 2 minutes and use the definite property of the definite integral to calculate the definite integral of this one. Once you have the answer, leave in the link above. Okay, I have one more problem. In this problem, I have given the net change from 2 to 5 of the function f and g, and I need to calculate the net change of the function f minus 2 time function g of x, g of g. So the subtraction property say that the net change from 5 to 2 of the function f for the function g will be minus net change from 5 to 2 of 2 times t of g, and then this will be 5 to 2 z dz, and then you can pull out 2 because 2 is a constant. It can be pulled out the sign of the integration, and g dg, because the limit of the integration is starting from 5 to 2, it's going from right to left. If I switch the integrations limit 2 to 5, so it will give me a negative sign in front. Here is a negative, this will become positive. So it's 5 to 2 to 5. Let's give me the net change 2 to 5. Now these values I have given. So the first value is 2 to 5 f is a 2 unit. So it's a minus 2 plus 2 times z function. So this is a z function, sorry. G function is a negative 1. So it's a negative 1. So total net change is negative 4. So that is my answer for the problem. I have some more property of the definite integral. These properties are known as the integral comparison property or integral comparison test sometime, which says that if a function is positive, it means if the function is above the x-axis, the net change in the function will be a positive, because it is also, if the function is a positive, it means the graph of the function is above the x-axis and there is a no portion of the function which is below. So that will be just the net, the total area of the graph, the total area under the graph of the function. And area is a positive quantity, so it will be a positive integral. Second is, if the function, one function is greater than the another function, then the net change of the function will also hold the same property. It means if the one function is above the graph of the another function, then the area under this graph will be more than the area under that graph. The last one, the property number 3, is the integral comparison test, which says that if the function is bounded between two constants, the definite integral will be bounded between these two numbers, which is basically the area, the minimum area of that rectangle. So this geometrically, they say that if the function is between these two limits, the maximum value, this is the absolute min and absolute max of on the interval a to b, if interval a to b is that, then this function, this area is, this is the area below, this is the minimum area, and that is the maximum area. The function will stay between these two. The net change of the function will stay between these two numbers. Let's practice this property number 3 on this example. So we will ask to estimate the value of this definite integral which is the square root of 1 plus x squared dx. Without looking at the shape of the graph of the functions, we will basically estimate what is the lower and the upper limit of this definite integral. So as you can see that our x is between 0 less than 1. So that means x square will be also between 0 and 1, because if I square on the inequality, it won't change. If I add 1 on both side of the inequality, it's going to be x square is between 1 and 2. If I change the square root, because it's an increasing function, so it will not change the sign of the inequality. So that means tell me my function 1 plus x square, the square root of that function is between these two numbers. This is the lower bound of my function, and that is my upper bound of the function when my x is 0 less than 1. And I'm between 0 and 1. This is my lower, and that's my upper upper bound of the function. So now I will use the property number 3, which says that if the function has this is the lower bound and this is the upper bound, the definite integral will stay between the definite integral. So therefore, the definite integral of, if I take the definite integral on both sides from 0 to 1 of 1 dx, that's going to be less than is equal to 0 to 1 square root of 1 plus x square dx is going to be 0 to 1 and square root of 2 dx. We know that if the constant, the definite integral is a constant time upper limit minus lower limit, less than is equal to 0 to 1 1 plus x square dx, and this is the constant time upper minus lower limit. This is a 1, this is less than is equal to 0 to 1 square root 1 plus x square dx less than is equal to square root. So this is my upper and lower bound of my definite integral, the square root of 1 plus x square. So this is the net change. It will be always greater than 1, but it will be always less than square root of 2. This is all I have in this video, and if you like the video, subscribe my channel and hit the bell button so you can get the next video. Bye for now. I will see you in the next video.